Okay, welcome back to Calculus 2 here. So we are looking at alternating series now. So we have the series -1 raised to the nth power. Well, this should be n starts at 2. Okay, of ln of n over n. And in order to use an alternating series test, so first off, check it is a series. Check it is alternating because we have this -1 raised to the nth power. So it's going to be positive and negative because n starts at 2. So it is alternating. So we have the first thing to do is click the zeroth thing to deal with is this thing an actual alternating series? Okay. So second thing is this a sub n piece. So is every ln of n over n, is this greater than or equal to 0 for all my n's and starting at 2? And I think we could safely say by inspection, yes, it is. We can go ahead and say ln of n is greater than 0, n is greater than 0. We have positive, we have greater than 0 over greater than 0. We are greater than 0. Okay, so we are positive for both of these pieces here. Okay, or you could say, hey, this is positive, this is positive. Positive over positive is going to be positive. It's greater than 0. So we have, we have first condition is kind of set up here. Second thing, is it decreasing? So what I'm going to do is I'm going to say, instead of my f of n, I'm going to say f of x, which is going to be ln of x over x, because what I want to do is I want to take a derivative to see if this is actually a decreasing function. And we have to take derivatives of continuous functions, not discontinuous ones. So we don't want to do n's, we want to do x's instead. So f prime of x is equal to, so let's go ahead and say, well, before I get to f prime, let's rewrite this so I can actually take a derivative here. So let's rewrite this a little bit. So this is going to be f of x is equal to x to the -1 times natural log of x. Okay. You could use the quotient rule too. That's fine. I'm used to using the product rule, so I'm going to do that. So in order to use the product rule, we have to say derivative of the first, so it's negative x raised to the -2 times the second function plus the first, that's x to the -1, times the derivative of the second function here. So we're going to say, simplify this out. We have negative ln of x over x squared. That's what this piece is going to look like. And then we have plus 1 over x, this x to the -1 times x to the -1. This is 1 over x squared. So let's go ahead and combine this up a little bit and rearrange. So we have 1 minus natural log of x all over x squared. So x squared is going to be greater than 0. And now we have to see, where is 1 minus ln of x equal to 0? So we can check that out. And we go ahead and we say, okay, well, we have 1 is equal to the natural log of x, right? You just put this on the other side. Now we're going to unlogify it. We have x equals e, okay? So about 3, right? That's where it's, after that it's going to be a positive, or yeah, it's going to be a positive number. So we could say, okay, sorry. So yeah, after that it's going to be a negative number. So we have, so once we have natural log of e, right? If it was e, we would have equal to 0. But anything bigger than e, we have 1 minus something that's bigger than 1. That's going to be a negative number. So we're going to be able to say this is going to be a negative value. This is going to be a positive value. Negative over positive means that this whole function is going to be less than 0. Okay, for all of my values that's bigger than 3. Since we start at 2, then we have one little time where it goes up, and then for the rest of time, it goes down. Okay, so that's what we pretty much have. So we have a decreasing function over most of our domain, or most all of it. And now we have to see, is the limit as this function goes down, is this limit of the series go to 0? So I'm going to say, what's the limit as x goes to infinity of natural log of x over x? So we plug in infinity and we get infinity over infinity. It's like, oh, if I didn't know any better, I'd say that's an indeterminate form. We can use L'Hopital's on this, right? So we indeterminate form, use L'Hopital's on this. So we take the derivative of the top, we get 1 over x. We take the derivative of the bottom, we get 1. So we end up with 1 over x as the limit as x goes off to infinity. This limit goes off to 0. So hey, we have that third condition fixed. So we have, yes, the a sub n's are greater than 0, f of n's are decreasing, and the sum goes to 0. We're allowed to go ahead and apply the alternating series test. If these 3 conditions are met, then the series converges. Okay, so yes, ln of n over n, sum from n goes to 2 off to infinity, converges, let's put the -1 in there, by alternating series test. Okay, we're going to say alternating series test. We'll just abbreviate as AST there. Okay, so that's how you do a problem like that. The important thing is we checked through all the conditions, we showed all the conditions, and then that's how we're applying that test. Okay, so I'm going to say thank you very much for watching my video. I'll see you in the next one and take care until then. Okay, and program.